Hello, today's lab we are going to look at inductors. And today's one of the first labs that we'll be using an oscilloscope. An oscilloscope is a way to display voltage as a function of time. And actually that grid you see is just that, it's a graph with voltage on the y and time on the x, where the axes you are set with various pieces. Right now we are just setting it up and I am hooking it up to a function generator. This function generator is putting out a wave with a 100 hertz wave that is a square wave. And what I would do is I would display this on my oscilloscope. And that's what you get. It's either up or down, up or down. Right now I have my oscilloscope set with a sweep time of 1 millisecond per centimeter, which means each one of these big old boxes, and I'm gonna zoom in a little bit on this. Each one of those big old boxes is 1 millisecond, and on the y-axis, which I can adjust to go bigger or smaller, I right now have it set that each centimeter block is 2 centimeters. So that this went down 2 volts, and here it's going up 2 volts. Now this is just an output. That's not really doing anything right now, but I'm going to use this in a RL circuit. Well, basically, I'm going to have it going and putting this voltage being, it's basically a voltage turning on, off, and put it on an inductor and see how the voltage travels as a function of time. So, I'm going to start kind of setting this up, but I will quickly show you that for my circuit, what I have is I have a resistor and an inductor. This big thing right here is a 10 Henry inductor that is hooked up in series with this resistor. This first resistor is a 10 kilo ohm resistor. Sorry, there you go. I'm using a breadboard just to try to attach them without doing any actual attaching. So, if I just give a quick clip, you can see that, or quick cut, you can see them attached like so. Okay, and what I can assume was a very awkward jump cut. We now are hooked up. What we have is my function generator here is hooked up on either side of the circuit, where it's coming in, you know what, I can just take these off for a second. Where it's coming into one side of the resistor goes to the inductor, then out the other side of the inductor. So this whole circuit is connecting both of them. These other two that I'm reattaching on either side of my resistor, that is the oscilloscope. And so this is going to, what the oscilloscope is going to read is the voltage on the resistor. So let's take a look at that. Here we go. There's my voltage on the resistor. Now what you're seeing is that, as an RL circuit, that the voltage going up and down. Today we're going to do math for discharging, which is equation number 7, or 6 and 7 really. And what I'm going to do is I'm going to figure out how long it takes for the thing to discharge halfway. Now, of note, on my function generator, I can mess with the amplitude. And what I'm going to do is I'm going to make my amplitude a nice number so that my maximum to minimum matches a nice spot. I also have an up, down, and left-right control of my oscilloscope, which has no meaning. So I will just go and line things up. And what I have now is that my highest is 2 squares up, and my lowest is 2 squares down. And since I'm looking for my halfway point, that'll be wherever I cross the 0. And I want to find what time it takes to hit that point. So I'm going to line my max up to my 0 on my x-axis, and I'm going to find out what the x value is. Now, what I can see here is that it crosses at 1, 2, basically right at 3. Oh, sorry, each one of those is 2. So right at 6 millimeters, or 0.6 centimeters. Now, that tells me that the time, yeah, it's 0.6 centimeters, but that doesn't really explain anything. But keep in mind, I'm working at 1 millisecond per frame, which means each big box is 1 millisecond. So if it's 0.6 centimeters, and each centimeter is 1 millisecond, that means my time is 0.6 milliseconds. It will be on you to find the theoretical value. We will then repeat this for various resistors, which I'll switch them out and give you the output of the resistors. So here's my next resistor, where this resistor is the 15 kilo ohm. And I'll do the same thing. I will line everything up I may bring down my amplitude a tiny bit. And then I'll figure out where it goes halfway. This looks basically right in the second tick mark, which is 0.4. So this is 0.4 milliseconds. And then if I want to look at my last resistor, which is the 20 kilo ohm resistor, I'll do the same thing, where I'll go, line up my 0. I'm going to mess with my amplitude a tiny bit again and find where it crosses. And I'm finding this a little, probably like if each of these 6 is 0.2, I'd say about 0.3. So I'm going to give this a 0.3 milliseconds. And from there we can start trying to solve for everything.